Uniforms ain't uniform. Science uses the word uniform to describe certain states of the so-called magnetic field. In one instance, the field in the middle of a coreless cylindrical coil is said to be uniform because here the lines of force are parallel. What it means, where there are parallel lines of force, then there is no attraction on a speck of iron placed there. These lines are often incorrectly drawn equidistant from each other, whereas they should show their spacing increasing from the coil to the centre. If there were a gap in the middle of this cylindrical coil and a charged particle were fired through the gap, then it would be subjected to a force which is perpendicular to its direction. However, this force would be variable. It would increase as it moves towards the centre. Why this happens becomes clear if we look at the MeFlow 2 version of magnetism, which describes a vortex in the middle of the coil. The perpendicular force on a charged particle entering the coilless gap is zero because there is a crosswind vortex flow here at right angles to it. This force rises to a maximum as it passes through the central regions, where it is both pulled up by coparallel flow and pushed up by antiparallel flow. It then falls back to zero as it departs. Its path is more or less hyperbolic, not helical or spiral. In another instance, the field across a small gap between two opposite pole magnets or electromagnets is said to be uniform because the theoretical lines of force, here shown going into the page, are parallel and correctly equidistant. When a charged particle traverses this gap, it is subject to a force perpendicular to its motion, which is uniform and constant. Its path is helical. The magnetism in magnets comes from electrons generating magnetic vortexes as they orbit around their atoms and molecules and around the atomic lattice that contains them. When vortexes are rotating the same way on the same central axis, they augment each other, forming wobbly columns. If an atomic orbit with the same rotations is beside another one with the same rotation, the vortexes are antiparallel at their tangent contact points, therefore they repel each other. These form independent columns. Thus, along the length of a magnet, there are columns of individual vortexes all spinning the same direction and all mutually repulsive. Thousands of these per square centimetre emerge from the magnetic pole. Once free of the constraints of their metal bonds, they expand rapidly, causing them to burst away from each other. The expansion turns the outer columns so far that they join the outer columns from the other end. The familiar iron filing patterns are caused by iron filings linking along the axis or the eyes of these vortex columns. Whether or not the vortexes merge after a short distance is discussed at length in MeFlow 2. In the gap between two opposite pole magnets, the central individual columns from one pole interlink with those from the other pole, with limited expansion, if any. When a charged particle traverses this gap, its own wings of magnetism traverse thousands of magnetic vortexes, each of which delivers a minute force which is transferred back to the particle. Collectively, this force is observed to be constant or uniform. I believe there are minute variations. It is the iron core which enables uniform magnetism. Coreless cylindrical coils do not. All books should be revised.